today's video, I want to take a look at finding the area of the region bounded by the graphs of some given equation. So when we're looking for the area bounded by two equations, what we really want to know is, well, am I taking, for example, am I going to do x minus x to the fourth, or is it x to the fourth minus x? So understanding which one's on top and which one's on bottom. And then the second part that we have to understand is what are going to be my limits of integration? Am I going to go from -1 to 2, 0 to 2, 0 to 1, 1 to 3? Like, where are they intersecting one another? Like, what is that point? So there's a number of different ways that you can do this. You can graph it in a TI-84, TI-83, figure it out that way. You can do algebra. But I'm just going to go with the route of saying x is equal to x to the fourth. So this is what I want to know. I want to know when are these two functions equal to one another. And then I'm just going to solve. So I'm going to have 0 equals x to the fourth minus x. Take out an x. So I have x times x to the third minus 1. So then you could say, well, this x is equal to 0. This factor is equal to 0. So we get x equal to 0. You could do a couple of different things with this x to the third minus 1. I'm just going to go the route of just adding 1. You get x to the third equals 1. Then take the cube root of both sides, and you get x equals 1. You could do a difference of 2 cubes, and then you just get like x minus 1 times something else. And then that x minus 1 would be the only thing that you could do anything with. So we know that these are going to intersect one another at 0 and 1. And go to your calculator, type those in, and you'll see that they cross paths at 0 and 1. So we know our limits of integration. We're going to integrate from 0 to 1. Now we really want to make sure, though, is it x? Is it this function minus that function, or is it this function minus that function? And that's where maybe you might need a calculator to help you out if you're not too sure with what these graphs look like. And if you're pretty experienced with graphs and understanding y equals x, it's just going to be a line, x to the fourth, it's going to be a parabola. If you're pretty good with graphs and understand the properties of them, then you should be hopefully okay. But if you want to throw it into a graph and just throw it into your calculator, really not too difficult. And it looks something like this. I don't know how well you could see that. Sometimes the camera reflects and doesn't focus on it very well, but you could tell that it's going to look like this. So it's going to be y equals x is like that. And then x to the fourth is going to be like that. So it's going to be from 0 to 1, where x, this green line, is above the red. So we're looking for that zone right there. So we're going to do x minus x to the fourth dx. And then from here, it's just a normal integration problem. So I'm going to have x to the second over 2 minus x to the fifth over 5 from 0 to 1. Plug in 1, so I'm going to have 1 squared, which is 1 over 2, minus 1 to the fifth, which is 1 over 5. And this is just going to be minus zeros all around, 0 minus 0. So we just have 1/2 minus 1/5 is pretty much all we're looking at here. So that's going to be 2 times 5 is 10, times 5 times 2 times 2. So 5 minus 2 is 3, so 3/10. So the area of the region bounded by these two graphs, y equals x and x to the fourth, is going to be 3/10. And a couple different ways you could do this part is you could do this algebraically like I just did, or if you have a calculator, go to your calculator, and there are ways of getting those intersecting points by hitting intersect, option 5 on second calc. If you go into that tab, it says intersect, and you can get the intersect points, something that you probably looked at before. But two options there. And then to figure out, is it x minus x to the fourth or x to the fourth minus x, understanding properties of your graphs. Or again, go to your graphing calculator, and you'll see that that y equals x is above that graph here, y equals x, and then that graph. So I'm just zooming this in on my paper here. So this is what it looks like. This is x to the fourth, and you can see x is above the x to the fourth. So we go from 0 to 1. All right, hopefully this helps you out with that problem.